Hi, and welcome to TEMEKO. This video introduces an essential ingredient for the study of vibrations in machines, excitations. We will look at the main causes of these excitations and why they are important and what are the most common types of excitations: harmonic, impulse, and rotating excitations. By the end of this video, you will be able to recognize and relate all these concepts to any application under study without hesitation. In simple terms, excitations in a vibrating system are forces that induce movement in such systems. The way these forces are presented to the system will allow to classify them and study the responses produced by these excitations. If the excitations are such that they can be described by a periodic function, that is, for example, if we are in the presence of an external sinusoidal linear force acting at a certain frequency, then we can say that we are in the presence of a harmonic excitation. A sinusoidal, cosine, or combination of them can be examples of periodic forces. The characteristics of harmonic excitations are very interesting. They can lead to large displacements, which can cause the system to exceed the elastic ranges of their components, resulting in structural failure. Do you have an application in mind where you could have seen a harmonic excitation? Maybe you have heard of bridges collapsing after soldiers marching on them, or wind blowing to them. This is very tied to the concept of resonance, which in this case would be the response to the harmonic excitations. We can also have impulses. If you have ever played or seen a sport which includes any kind of ball, you must have witnessed the concept of impulse. To understand what impulse is, we need to define the concept of momentum. Momentum, in a very simple definition, imagine this, is how hard would you have to act against an object to stop its movement? If we look at the formula to estimate momentum, P equals m times v, where P is the momentum, m is the mass, and v is the velocity, you will immediately see that momentum depends, among other things, on how fast the object is moving. Now, if to an object, static or moving, we apply a force for a short amount of time, the object will change its velocity. That will change the object's momentum. Of course, it depends on the magnitude of this force in comparison with the object mass. So an impulse excitation is that short-time acting force that changes the momentum of the object where this force is applied. Fun, isn't it? It is important to mention that impulse excitations by its own nature can be very destructive. As in the case of harmonic excitations, a short force could cause the material to exceed its yield strength, producing a localized, if not complete, failure. Now, the last form of excitation we will talk about is torsional excitation. A torsional excitation resembles those already explained previously, harmonic excitation and impulse, in the sense that instead of being linear, the forces are introduced to the system in the form of torque in a rotational system. Do you have another application in mind where you could have seen a torsional harmonic excitation? You might have seen it in a washing machine. Funny, isn't it? When the clothes are unevenly distributed, the drum in the washing machine behaves like it were subjected to a harmonic force, making it rotate uncontrollably at certain speeds. After seeing concepts discussed here, one can conclude that there would be no motion without excitations. Any force or torque applied to a system can be considered an excitation. However, we wanted to focus on harmonic, impulse, and torsional excitations, as most of the times they are not desirable to have. Remember the cases of the bridge and the washing machine? If we get to the core of dynamic problems, excitations of the type mentioned can be translated into having some external forces affecting the system, increasing its total amount of energy with possible damaging consequences. Hopefully, this video will help you see the importance of knowing the forces in the form of excitations affecting the system under study. It is probable that excitations cannot be isolated completely, but they need to be controlled to avoid any serious damage. Thanks for watching. We hope you enjoyed this one. Stay with us and keep learning these interesting topics.